Greetings and welcome. Me and my friend Devin are here. We're just doing some math as bros. Actually, there's other people here, but really, I'm only here to teach him math. And then everyone else, they just get to hang out, but that's fine. So here we go. We're going to talk about solving systems by elimination. And there's a problem with this problem, number 7 specifically. My students told me about it. What is the problem with number 7? Could someone articulate the problem? The problem is there are no opposite variables here. Okay, gentlemen, please. There are no opposite variables here. 3x and 6x will not eliminate each other. Negative 4y, Ethan, and 9y will not eliminate each other. We've got a problem. So what I'm going to try to do is try to find the least common multiple between 3 and 6. Smaller. 6. All right, check this out. If I want to find the least common multiple of 3 and 6, 3 goes in with itself, but 6 doesn't. 3 and 6 both go into 6. Hooray. Actually, I wonder, does this one show up in projector mode? Oh, that's gorgeous, guys. Look at that. Wow, I'm so pumped. Right, 12 would work, 18, those work. They're just not the least, okay? Let's see, between 4 and 9, what's the least number that 4 and 9 go into? Here's 4. And 9. Wait a minute. That's not 4, that's 3. There we go. Yeah, it looks like 36, which, that's fine. Oh, the hundo, yeah, hundred. So 36 is actually the least common denominator for that, which also happens to be, right, the number that they both multiply to become. So step 1 of elimination method, Ethan, you might recall, was multiply one or both of the equations by a number, they use the word constant, in order to get opposite coefficients for one of your variables. Which number do you like better, 6 or 36? Why do we like it? It's smaller, right? We want to work with smaller numbers. So the question is, what could I multiply 3 by in order to get 6? 2. Now, that will give me a 6x, which still won't eliminate with a 6x. So I'm going to actually change that to a negative 2, so it'll be opposite. All right, so I've chosen this, and I actually recommend you even writing this work down. So like if on a test, even if you didn't have anything else, if you wrote down 6 and 36, I'd be like, I know what they're thinking about there, right? I would know what you're aiming for. So show this work. And so let's multiply through by negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 4y will be positive 8y. Equals negative 2 times 19 is negative 38. I'm multiplying this entire equation through by negative 2 so that I get the opposite coefficients that I want. So notice I made both of these some form of 6 or negative 6. That's the reason I do it. All right, I want opposite coefficients. And the reason I want that is because of step 2. You'll see right here, if I don't have opposite coefficients, this won't happen. What happens when I add 6x and negative 6x? Yeah, they get eliminated. That's an aux, right? 0x is 0, that's nothing. They're gone. This is what we wanted. 9y and 8y combined to be 17y equals 21 and negative 38. You could reach for a calculator, but I'll tell you, I believe that is negative 17. All right, so the first step is tricky. It requires a lot of planning, right? I want to get opposite coefficients. I got to find least common multiples and then multiply an equation through by some number, including, right, being careful with distribution. A lot of things, but it helps me out, right? It eliminated that variable. The other cool thing about this is if I tried solving by substitution, there's no weak spot in this equation. Substitution would have required a whole lot of fractions work, like lots of fraction work to solve it through. And elimination method is just oh so powerful. All right, step 3, let's solve this for y. What do I do? Being multiplied, so the inverse is to divide. Got to undo the multiplicado. So y, the 17s cancel out, so I'll have y equals, here those 17s cancel out, -1. All right. And now, that's only half of my answer. You with us, Ethan? Are you just playing with the multiples calculator over there? Or? Okay. Well, make sure you're learning this. Now, if I want to find x, cool thing is, I could plug this in here, I could plug this in here, or I could plug this in here. Which one do you guys like? Yeah, you could. I mean, I think I like this one only because these numbers seem to be smaller than all the other ones in general. But you will get the same answer whichever one you choose. So it doesn't matter. If you were like, I hate the number 4, you know, you could avoid it and whatever. So you get to pick. So let's see, step 4, plug it in to find the other variable. So 3x minus 4 times, and instead of y, I'm replacing it with -1 equals 19. 3x plus 4 equals 19. We'll subtract 4 from both sides. All right, you guys are becoming expert ninja solvers, right? So good. So pumped. This lesson, actually, this chapter combines like all of our previous chapters into one big idea. We're like dealing with lines, we're dealing with solving. It's all coming together. It is just like boss fight chapter. So my solution is 5, -1, which I want to point out, right, represents a point where these lines intersect, is what that represents. Okay, that's where these two lines would cross one another. Let's do another one together. You know what? Maybe we'll just get up to Ethan. Yeah, put that away. Yeah, you know, I don't need it. Focus with me, friend. All right, let's do at least steps 1 and 2 for these. I'm going to assume that you can do 3, the solving, and 4, the substituting from there on, just so that I can focus on this new skill, which is actually kind of hard. I'd rather us rehearse the new difficult piece together. So step 1, I want to get opposite coefficients. I do not currently have opposite coefficients. So for the x's, if I wanted opposite coefficients, right now I've got a 4 and a -3. What's the smallest number that both of those fit into? 4 and 3. That they multiply to become. Let's see, here's 4. Beep boop boop beep boop boop beep boop boop. Ah! Man, that was lagging out there for a second there. Nope. Ding! 12. Right? And you literally can just make a list of each of those. You could count by 4s. 4, 8, 12, 16, right? 20. Then count by 3s. 3, 6, 9, 12. And you're like, wait, 12 and 12, those are the same. And then like you'd be all happy and freaking out. That's what you can do. Thank you, Ethan. So here's 12. Let's see. I don't want to commit to getting opposite x's just yet. Let's see if maybe it's easier for the y's. What do 5 and 2 both go into? Nope. 10. Yeah, 10's the smallest. Yeah. And let's see. And you're not wrong if you want to use 20, right? Or 30 or 40. You're just working with a non-least common multiple. All right? So when I do this, I write down both of these numbers, and then I'm like, which one do I want to work with? I'm going to go for the smaller number. That's what I'm going to do. So now the question is, what would I have to multiply this equation by to get a 5 to become a 10? Dose, right? So I'm going to multiply this equation by 2. Okay? Now, the problem is, this is not a 10 either, right? At least over here, this one was already a 6, right? I only had to multiply one of the equations. It looks like I'm going to have to multiply both of these equations by something. What can I multiply 2 by to get 10? 5, and I want one of these to be opposite. So right now they'd both be positive 10y. So I'm going to make this a negative 5, but you also could have made the 2 negative. It doesn't matter. It doesn't matter which one you do. Don't matter none. Let's multiply this through. You ready for this, Pooja? This is going to be crazy. Crazy sauce. Here we go. 2 times 4x is 8x. 2 times 5y is 10y. Equals 2 times 3. Don't forget that right-hand side. Equal to 6. Now, trickier, I've got to distribute a negative 5. Negative 5 times negative 3x is positive 15x. Negative 5 times 2y is negative 10y. Look at those gorgeous opposite coefficients. Question? Oh, dear. My goal is that these have opposite signs so that when I add them together, they get eliminated. Yep, because if I did positive 2, I would have had a positive 6x, and 6x plus 6x would not have been 0. So my goal is that I'd have one positive, one negative, right? So that when I added them together, I in fact got 0 x's. We'll get good at this. It takes time. I think you guys probably agree this is a little bit tricky. Negative 190. Let's see. I think I agree. All right. So step 1, and then we'll do step 2 of adding it up just so we get the reward of the elimination process. 8x plus 15x would have been 23x. And look at this. Look out, Y's. You are eliminated. Man. This would be the coolest reality TV show or something. Solving systems of equations. America's next top system of equations. Right? You are eliminated. And then, bam. Oh, it'd be so great. So let's see. These combine. This is negative 184. And then you guys would solve it from there. But let's keep looking at some more, because this is the new tricky step for us, right? Tricky. Let's do number 9. We're gonna practice so we get better at things. Can you believe the things that we get better at? All right. We'll do 9 and 10. Okay. Yeah. All right. Step 1, get those opposite coefficients. Question. Let's see how speedy we can get. What do 8 and 5 go into? 40. There ain't nothing smaller. What do 2 and 3 go into? 6. Let's work with the 6. What could I multiply 2 by to get 6? 3. So I'd multiply the entire equation by 3. What do I multiply negative 3 by to get 6? Right. Or yeah. All right. Yeah, no bottle flipping. Thank you. 3 times 2 is 6. And actually, good news, these already had opposite signs. So I'm just going to leave that as 3 and 2 here. All right. Because I want them to be opposite. 3 times 8x is 24x, Devin. Don't distract my student. 3 times 8x is 24x. 3 times 2y is plus 6y equals 3 times 22 is 66. 2 times 5x, next equation, 10x. 2 times negative 3y. Look at this. We got our opposites we wanted. Oh, man, it's lining up. And 2 times 35 is 70. And then you would add them together. And right, the big deal is that these get eliminated. We're not even going to do that part. I'll let you finish writing it, though, before we look at 10 together. But yeah, I think you guys agree that you wouldn't have wanted to choose the 40. But if you do that on a test, I'm not going to mark you wrong. I'm just going to feel bad that you had to work harder than everyone else. Right? I'm showing you guys the easy way. Right? Also, if you tried solving this using, like, substitution method, oh, man, I'm so sorry. you're going to have some ugly fractions for like 10 minutes. Right, Devin? That's right. Okay, 4 and 6. What's a number that these go into? We're not even finishing them. 24. What's a smaller number they go into? 12. How about 3 and 7? 21. Let's choose 12. Because we're only doing the more difficult steps right now. Nope. 4 times what is 12? 3. 6 times what is 12? 2. One of those needs to be negative. Which one do you want? Doesn't matter. All right, we could do it different ways. We'll diverge and we'll see what eliminates. I don't care if I have a negative 12x on the first one and a positive 12x on the bottom, or vice versa. They'll still be eliminated. All right? Yeah. Let's see. 3 times 4x is 12x. 3 times 7y, 21y. 3 times 1 is 3. Let's have you guys distribute this next one. All right? I'll walk around. So let's see, negative 2 times negative 3y. You can still grab the calculator. Positive 6y. Negative 2 times 15 is negative 30. And who gets eliminated? Those x's get eliminated. Yeah, and then the rest of the problem goes from there. All right? Now, guys, you don't even have this one on your packet. But let's take a look at 11 together. All right? So you're not even writing this down. You're doing this with me. Right? I am your pen, you are my brain. Don't worry. Yeah, I know. Don't even write it down. It's gone crazy. 21 and 14. Ooh, dear. What's the smallest number they both go into? 42, maybe? Does 14 go into 42? No, I think it's going to be 60. Let's write a list, right? 14, 28. Oh, 42. Okay, so 42 is the one, right? 21, 42. If you just count by those numbers, okay. Either way, I don't. Oh, actually, this one we might be stuck with. How about 11 and 8? I think it's 88. Yeah. Ugh. So, 21 multiplied by what is 42? Gentlemen, we're asking a question here. 21 times what is 42? 2. Ethan, completely unrelated. Stick with me. Stop hurting my friends. Negative 14 times what? Or 14 times what is 42? And you actually can even count that out here. Notice right here was 1 times 14 was that, right? 2 times was that, 3 times is that. And hey, look at this. Do I need one of these to be negative or positive? Devin, never need. Yep. Let's see. So I got a 3. These are already opposite. One's positive, one's negative. So we're good. We're good, friends. So step 1, let's distribute. 2 times 21x, 42x. 2 times negative 11y, negative 22y. 2 times negative 9, negative 18, right? You can grab a calculator for those. That's fine. And let's see. Let's do the bottom one. Let's have you guys do that one. We're multiplying. So let's see. 3 times negative 14. Now we're moving quick. Don't worry. You'll have practice. 3 times 8, 24. 3 times 4, 12. How cool is this? I add them up. What happens? Those are eliminated. Right? And then you could solve it from there. All right. This one I absolutely know is not on your paper. Number 12. Oh, is it? All right, let's see. Let's get... So, Devin, help me out. 3 and 2. What's the smallest number? Ethan. Devin. 6. Too late. Yeah, you guys are too slow. 6 and 9. What's the smallest number they go into? Nope. There's... All right. So, if you used 54, it would work out. It would work out just fine. It wouldn't be wrong. It would be right. It would just be harder. And that's okay. So let's work with the 6, right? Because that's smaller. What 3 times what is 6? 2. 2 times what is 6? 3. Do I need one of these to be negative? Why? Because this is already positive, this is already negative. They're opposites, they're going to get eliminated. All right, you guys are good. You're getting good at this. I gotta say, you're getting good at this. I like this. You're making me so proud. 2 times 3x is 6x. 2 times 6y is 12e. 2 times 6 is 12. 3 times negative 2 is negative 6x. 3 times 9e is negative 18e. And 3 times negative 24 is what? Negative 72? And check out how cool this is. What gets eliminated? Bam. No, could be the y's. I mean, if I chose 18 here, then we would have ended up getting opposite coefficients for the y's, and those would have been eliminated. All right, so guys, check this out. We're going to do one more example, but I want to talk to you guys about what works best when. You can find this chart in your packet. It turns out graphing is great to estimate solutions, or to kind of like give you a visual understanding of something. Graphing is also great when we've been talking about systems of equations. Someday we might have equations like this and like this. And like solving by graphing might actually be really easy, where algebraically it would be super hard. And so graphing is a great way to start to do things. Substitution, we do substitution when there is a weak spot. Remember, that's what Waddy Toddy, right? I said that the other day, right? When there's a weak spot. One of my variables has a 1 or negative 1 coefficient. Elimination is best when there's opposite coefficients, or, right, when there's just numbers in front of everything, right? Coefficients all over, right? Elimination is awesome at that. Substitution still works. It just would create fractions. Let's do example 3 together. You guys have this in your packet. Flip around. Okay. So, last example. Variable, right? We're going to do VESA. Okay, variable. Where do I find the variables? No, at the end. It's the question they're asking. My variable should be able to answer this. What is the cost of each type of van? So I'm going to let the x equal the, okay, if this is cost, my variable is going to be cost of what? Let's see, what kind of vans are there? It looks like they've got large and small. Okay, so I'll have x be the cost of a large van. They mentioned that first. And what should this be measured in? What type of money? Why did we choose dollars? Because they chose dollars, right? If they were talking euros or pesos or fesos or quesos, right? Whatever it is. Yeah, just a currency, right? Yeah. Y will have represent the cost of a small van, also in American dollars. Okay, here's the tricky part. Let's see if we can piece some clues together to write some equations. It says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. All right. Wait a minute. Location A receives 5 large vans and 2 small vans. Okay, that's actually not that helpful, I don't think. Yeah, I don't think that's all that helpful. I think it's this next sentence that's going to be more helpful. All right, so they're saying location A receives 5 large vans and 2 small vans for a total cost of this. Yeah. But he paid the price though, you know what I'm saying? You know what I'm saying. Let's see. 5 large vans. So the number of vans multiplied by the cost of large vans, that's going to be how much money that location spent on large vans. Plus 2 small vans. Okay, so 2 is the number of them, multiplied by the cost of them, and the total cost they spent was $235,000. All right, let's write another equation. What's their second fact? Location B receives 2 large vans and 3 small vans. Someone tell me what this equation is. Wait, what's the equation in x's and y's and numbers? 2x plus 3y. Yeah, 160,000 there. Bam. And if I want to solve this, we are not going to solve this the whole way. Okay, here we are. Here's my slider. If I want to solve this, which method would you rather use? Graphing, substitution, or elimination? Elimination, because substitution would create fractions. None of these individual variables had a positive 1 or negative 1 coefficient. But elimination, I can done do it. Elimination can work on every problem. Yep. Even if there was a weak spot, elimination will still work on it great. You got to know all 3 methods, actually. All right, so guys, yep, thank you, Ethan. That's 10. How about what's the least common multiple of these? 6. Let's work with 6. What do I multiply this equation through by? 2 times what is 6? 3. And what would I multiply this equation by? For this 3 to become a 6. 3 times what is 6? 2. Right, these are both positive now, so yeah, I'll make the second one negative. All right, and I'm not even going to multiply that out. I don't care about our ability to multiply large numbers. I care about our ability to use elimination method. All right, and then the problem goes from here. If you want to know how it works, don't you fret. Tell you what, here's the book's answer. I'll put it up here in case So guys, check this out. If you multiplied those out, you'd get something like these. You would have added them together. The x's would get eliminated. You would divide both sides by -11, and you'd end up getting x equals 35,000. What does x represent in our problem? X is the cost of a large van, right? That's not the number of gummy bears you can fit in a large van. I don't know. That's not the number of cats you can fit in a large van. Nope. That is the cost of that van in dollars. And then we would have taken this and plugged this into either of the original equations, x's, or our modified equations. It doesn't even matter. I probably would have chosen this one because these are smaller numbers, Ethan. And then I'd solve for y. And so notice then they wrote an answer. Bam, there's the answer if you want it. I figured you guys were all like, well, what about these vans? How much do these vans cost? Because I know you guys are so passionate. I figured I'd let you know. Thanks for watching, Internet friends. Adios.